Let's do a practice problem using the chi-square equation. Remember, this is an equation that's going to analyze differences in data due to chance or a variable being tested. In this equation, x squared is going to stand for chi-square. This big E looking thing is called the summation sign. That just means we're going to sum all the numbers. O is going to be our observed values. E is going to represent the expected values. Because remember, we're analyzing the observed versus the expected values in this equation. All right, so here's our example problem. We flip a coin 100 times and we get 53 heads and 47 tails. Now we should expect to get 50-50, 50 heads, 50 tails. But we don't get that, so we're trying to test if this is in the realm of possibility. So our expected for both the heads and tails is 50. However, the observed for heads is 53, and the observed for tails is 47. So we have to plug those numbers in with this equation. So on this side, we're going to do heads first, 53 minus 50 squared over 50. This side's going to be tails, 47 minus 50 squared over 50. 53 minus 50 is 3. 47 minus 50 is negative 3. And remember, that big E just means we have to sum both of these numbers or add them together. So 3 squared is 9, and negative 3 squared is also 9. So we have 9 over 50 plus 9 over 50, which is going to be 18 over 50 because we're going to add those together, which means our chi-square is 0.36. One of the biggest mistakes I see students make is they want to square root this to get x. Remember, that x square literally means chi-square, so the chi-square is this number. So now we're going to use that chi-square chart. Remember, we have to find our degrees of freedom. That's the number of variables, or n minus 1. In this case, our n, or the number of outcomes, is going to be 2, heads or tails. That means it's going to be 2 minus 1, which is 1, which means we're on that first degree of freedom, and we're going to use this first line. So again, we're looking at this degree of freedom all the way over. In AP Biology, I know we use 0.05 for our confidence rating. That's our p-value. So that means our critical value for our data is going to be 3.841. So what we have to do is we have to figure out where this 0.36 falls in that first degree of freedom. Let's start over here. Is it larger than 10? Of course not. It's not between 10 and 6. It's not between 6 and 5. It's not between 5 and 3. It's not between 3 and 2. It's on this side. It's much smaller than this number, which means our p-value is larger than 0.05. We don't actually need to know what our p-value is. We just need to know if it's larger or smaller than 0.05. And since it's larger than 0.05, we fail to reject the null hypothesis. And this should kind of make sense. Our null hypothesis states there's no significant difference between the expected and observed values. Yeah, that should make sense. If we flip a coin and get 53 heads and 47 tails, that sounds like it's in the realm of possibility. But we can't just say it's in the realm. We have to statistically analyze the data. And we do that using the chi-square test.